For example 1, we have the graph of y equals x squared. And this was generated in Desmos, really easy to do. So I just typed in y equals x caret 2, and it gave me the exponent, and this is the graph that showed up. Maybe just to label a couple of points on it, like a good reference point would be here, which is 0, 0. And another one here is going to be 2, 4. If you square 2, you get 4. Maybe one last one. If you square negative 2, you also get positive 4. Anyways, this is our graph of y equals x squared, a parabola. Now, if we want to graph y is equal to x minus 3 squared plus 1, you can actually just type this right into Desmos using the caret for the 2 exponent, parentheses, a plus 1. Very easy to do. But instead, I want to take the original graph. Note that this portion here means go right 3, and this 1 means go up 1. So you should have an idea of what this graph is going to look like. We could actually just take the 3 points that I just drew, move them 3 places to the right, and then up 1 place. So let's see. If I start with 0, 0, and I go 1, 2, 3 places this way, and then I go up 1, that's going to be the new location. So I think I'm just going to draw that on there. So that was 3, 1. Okay, I'll do that for the other points as well. So let's see. This was 2, 4. So I'm going to go 1, 2, 3, and up 1 to 5, 5. So I'll graph that. 5, 5. And the last point here, it's going to go 1, 2, 3, and up 1 to 1, 5. So my equation has to go through these 3 points, and it has to resemble the equation that we started with. So if I try to draw that, it doesn't have to be perfect, but I was going to come down like this and curve this way and do the same thing on the other side. So this is just to get a general sketch of the graph. So it should resemble the graph that we started with, but it's now in a different location. So what I'd like you to try is actually go into Desmos, or if you have a graphing calculator, you could use that too. And you would just type in open parentheses, x minus 3, use the symbol for an exponent and add a 1 at the end. The graph you get should resemble the one that I just sketched. So for example 2, same idea as the previous example where we're given this graph of y equals the square root of x. So when I typed this into Desmos, I wrote SQRT, open parentheses, x, close parentheses, and it gave me this symbol right here. So that was square root. If you're using an app on your phone, there should actually be a symbol like this for it that appears on your screen. You could use that too. Either way, this is my graph of the square root. If you want a couple of numbers off of it, well, 0, 0 is on the square root because the square root of 0 is 0. Maybe a couple of others. 4, 2, the square root of 4 is positive 2. And then a last one here at 9, the square root of 9 is 3. So same idea, I have this new function. It's y is equal to negative the square root of x plus 10. There's 2 things happening in this new function. I have this negative. I know this is going to reflect the y values. So we're going to go over the x-axis. That'll be a reflection. Now this plus 10 is going to mean go up 10 places. So I'm going to do that for the 3 points that I sketched and go from there. All right, so starting with 0, 0, it's on the x-axis, so that's this point right here. If you multiply the y value by -1, it does not go anywhere. And then if you add 10 to it, it's going to go up to 10. So I'll plot that point right here. Let's see. For my 2 other points, okay, that was 4, comma 2. If I reflect this y value, it's going to go from positive 2 to negative 2. And then if I add 10, it's going to go to positive 8. So let's see, I'll draw that spot right here. And then lastly, here we have 9 comma 3. So that's going to go to 9 comma negative 3. And then we're going to go up 10, which will take us to 7, which is right here. And I think I see what the shape of this graph is going to look like. It's going to resemble the function we started with, but it's going to be flipped upside down because we're making all of the y values negative. And it looks like this. Again, not like a perfect sketch, but something that you could, visualize before putting it into a graphing calculator. So again, you might want to try going into Desmos or a graphing calculator and type in negative the square root of x plus 10 and see if the graph that you get actually resembles the one that I have sketched here. And for the final example, example 3. So same idea. Here I've entered in the absolute value of x into Desmos using the letters A, B, S to actually get the equation in there. I'll choose a few points on the graph like, well, I know the absolute value of 0 is 0. And maybe the absolute value of 5 is 5. But where it gets interesting is, okay, the absolute value of negative 5 is also 5. Again, just choosing 3 points to see where they go on my new graph. So the new function is y is equal to 2 times the absolute value of x minus 10 minus 5. If I write out what this function does in order, I know this is going to go right 10. We're now outside of the function, so we're going to double the y values. And then, again, this minus 5 is outside of the function as well, so we're going to go down 5. We're subtracting 5 from every single y value. So let's think about where these points go. You could start with any one that you want. I think we could start with this one, 5, 5. Okay, we're going to go right 10. We're going to double the y value, which is at 5, meaning it goes up to 10. But then we're going to subtract 5 from it, and it ends up at 15 comma 5. So let me mark that, 15 comma 5. And we'll do the same thing for the remaining points. So let's see. Here's 0, 0. It's going to go right 10. The y value is 0, so if we double it, it doesn't go up or down. And then we're going to subtract 5 from it, and we end up at 10, negative 5. And for my final point, okay, negative 5, 5. 10 places to the right. Double the y value, but then subtracting 5 from it actually lands us right on this spot here. So those 2 points are common between the 2 graphs. If I want to sketch my final equation, it would look like this. And that makes sense. Like, the graph is definitely 10 to the right, it's down 5, but it's also steeper than the function that we started with. Anyways, I would try graphing this in a calculator or Desmos, and that is it for this example.